So the title of the seminar is LEDSimulator. So that's the main thing today. And for total color appearance, the reproduction. So we have 4 presentations today. From the 9 o'clock, and I will give a talk on the technology. And 10 o'clock, and my colleague Keith, Mr. Keith Hoover from the USA, he's going to talk about use case, the applications, and at 11 o'clock, the return on investment, also given by Keith. And starting from the 12 o'clock, and we will do a full demonstration of the systems, okay? So the planning is right, is each talk will last for 30, 40 minutes, and then with the question time, okay? I introduced, right, is myself, my name is Ronnier Luo. I'm the professor in the Zhejiang University, and both the kids and myself, we are the consultant and to work on the LEDSimulator project. So it is, a great honor to show you our, results over the last year, okay? So, and together with my colleagues, okay, and the team, and Mr. Zhang and Ms. Zhang, okay. So the scope of my talk, now I'm going to talk about the technology, okay? So this is the background, the technology, including the lighting quality, LEDSimulators, and the LEDSimulator divided into 3 parts: hardware, software, color management workflow, and colorway, color selection, and I will draw the conclusion, okay? So firstly, the background. So the whole, components in the supply chain can be divided into 3 parts. Okay, Keith will mention a lot on this. So the color exploitation, color specification, and color manufacturing. Okay, so from the design to the final product. So everything we look after, this will be looked after by us in the LEDSimulator system. So, and people are very familiar with the, textile trade. So we are talking about the supply chain management. And here, right, is you can see the designer, they are always in the front end. They do the color exploration, they invent the colors. They produce the seasonal color palette and then deliver to the brand makers, okay? The branding people, so they do the color specification, and then they will produce the shade card using the real sample together with the reflectance, and then finally, right, is the send to the, the dye house for color reproductions, okay? And however, this process has never been easy. It's been very much iterative. It's going around and around and around, and it's been wasting a lot of time. So let's talk about the color explorations, okay? The typical, and the tools used, right, is the color chart or fan deck, the Pantone, the Colourists, or different, color selection systems. The designers, right, they are looking for the ideas all year round, okay? What is the best product, and for this year? What is the background? What's happening, And they accumulated ideas using the different materials. Some of the textiles, some of them the paint, some of them even the plants, okay? So once they accumulate ideas, they needed to send all the color information and to the Dyers to do the lab dip. So lab dip, they will produce the shade card, okay? And then the actual swatches, and then send them to the branders, okay, for the final selections, okay? So the typical problem facing, right, is the all different materials. So you need to be reproduced and using the same substrate and the different colors. Okay, so that's a pain, isn't it? So color specification, this is for the branders, right? Is the, once they see these colors are coming from the designers. They don't have the textures. They don't know what is the materials, what is the text, okay? What is the texture? So this makes the overall process even more difficult, okay? So they will use the standard textures. The standard textures then transferred to the Dyers, okay? So, and this is the slide, the process I pinched from KISS. You will see this later. It's very iterative, many steps and very frustrations, okay? So then, right, is we're coming to, and the more recently, right, is the in the CIE, International Commission on Illumination. So we are responsible for the development of the color science. So we look at the total appearance, okay? So every individual product, so they got a very strong message, okay? So look at me, okay? Beautiful color, very nice textures, okay? And also, right, is the gloss and also translucencies, okay? So put all this together, that is the final product, okay? Which we are designing, okay? So we have done a lot of work in the color research. The color and is the well explored. We can say that. However, how can we and adding the components of the texture, the gloss, and the translucency to make a fine definition of the final product. So this is, we call it total appearance. The title of this topic is the, LEDSimulators for total color appearance, okay? The title of the today, is the LEDSimulator for the total appearance reproductions, okay? So now we're talking about the technology. We divide into two. One is lighting quality. Another one, right, is a LEDSimulator itself, okay? So look at it. Southern Light is starting everything with the high quality lightings, okay? So we are doing very well. We're selling, covering very well in the imaging areas, okay? So from the, all the famous, right, is the mobile phone companies, and car companies. Everything you use the digital camera, you need a calibration, and our systems will be there. So the lighting quality. So just look at the textile trade, right? We use the XYZ LAB every day, and we know, this is digital communication is very important, right? So very briefly, color science. So you need to have the light source, you need to have the object, you need to have vision systems. So the light source, we means the CIE defined the light source in terms of spectral power distribution, the object as a reflectance, and the human vision system will have 2 degree and 10 degree standard observers, okay? So everything's done by the computation. You measure the color, you got the reflectance. You compute, and then, right, is when you look at the samples, right, sometimes, or maybe frequently, you find that, oh, what I see is disagreed what's being measured. The XYZ LAB, no, it's not that so strong. Oh, it's reddish. It's not according to the numbers, okay? And a lot of reasons, right, it's because you applied the wrong light sources, okay? So the viewing cabinet, it's very important. And the quality of the light source inside is dominated. So how our eyes perceive the colors. So we needed to get in a very good, right, is the agreement between what you see of the physical product comparing with what is being measured from the color science, numbers. So CIE, you know, and is basically right define the whole range of the colors. Okay, so this is the famous right. It's the D illuminance, D65, and the illuminant A. These are the ISO CIE standard. And the F2, F11 is the being widely used in the office and in the store, TL84. Okay, but these are the fluorescent lights. But they are going. They've been phased out. What is the new, light sources coming? These are the 8, standard illuminants defined by the CIE. These are the LED sources. We are moving into the LED, era now. Okay. So if you go to buy the light source, sorry, you cannot buy the fluorescents easily. No tungsten bulb, it's gone. What we got, right, is LED. So you have the different color temperature, and then, so this is right, is the how we define what we call the color temperatures, okay? So this is, we call the, Planck radiators, okay? So it's all the white light sources. They are all located in this Planck illumination locus, okay? So we define the illuminance by the spectral power distribution, and also we define the color in terms of its color temperature. So in the southern light, right, is that we have the LED cube. This is the typical applications of the LED cubes in the ceiling, and this is for the measuring the quality of the camera, and this is the transmissive material measuring the HDR, high dynamic range lighting. And then everything is what we call the feedback systems. So if the color is wrong, we can adjust it, and so it can go a long way. Always maintain the accurate color reproduction. Why we can do that? Because our technology, right, is the spectral tunable LED systems. You give us any spectrals, and we can reproduce them using from the 11, 18, 11 to 18 LEDs. We can get accurate, reproduction in terms of the spectral. Okay, but no matter how you accurate, we will not be exactly reproduced because we only have 11 or 18 LEDs. Okay, so we go through the certification, go through the foreground. So we have the ASTM and the ISOs, okay? The typical tests, right, including the chromaticity, including the metamorphism index for the visual and for the UV, color rendering index, illuminance and the uniformity, neutral surround and the diffuse reflecting surface, and finally the maintenance, okay? So we go through every individual items, okay? So this is possibly the most important. We address this all the time, metabolism index, okay? So we define the 5 pairs of samples in terms of the spectral. And this 5 spectral means the 5 virtual samples. When you look at the daylight, no difference, color difference, 0. But once you insist the test source, and then CIE defines this as A, B, C, D, E grades, the average data E less than 0.25, A grade. B is the 0.25 and the 0.5. This gives you an example. So we have the 3 system tested. Our average value is 0.16, 17, and 16. So this is class 8. So this is the criteria is C. If you got a C, you passed. But our, and the grade is always A, okay? And also for the UV, there are 2 pairs of samples. This is for the UV. So our results, right, is and the tolerance is larger than 1.5, and ours is 0.93, 0.34, and 0.33. So all this, right, is passed. So if you look at the right, it's the daylight. It changes the sensitivity from the morning till night. So on the left, this is the CIE definition, and this is what we achieved using the 11 LED, spectrals. So if you look at the quality, T50, our CCT is the 5002 in terms of the, color temperature. CIERA is 99. 100, that means the, the actual appearance of the sample, they look exactly the same as the daylight, okay? So 99, 99.6, that's an excellent performance. And you can imagine MIVIS is all grade A, okay? So this is overall to summarize our results, okay? So our customers, right, is frequently including their, what do they call the store, illuminants. So for the cosmetic customers, they stored the spectrals of the different locations in London, in Paris, in New York, and also, right, they needed to reproduce this to evaluate their products, okay? So our most important, right, is the customers possibly, they are all in the imaging field. So you can have a look, right? They are the champions in the imaging field, and also the lighting field. And we got about 67 systems in the university and the research institutions. They've been widely spread, and because of the accurate control of the spectral and also the RA color rendering and MI, etc. Okay, so now I'm talking about the LED simulators. Okay, LED simulator, right? So you look at the LED simulator, okay, on its own. This is the front view. So what you see is an ordinary viewing cabinet and with the window on the wall. So what is in the back of the systems? We have two, what we call LED panels. These panels, right, is shining the light into the substrate in the 45-0 geometry. So this is what you see there. The light coming from the both ends. So you see the color there, and then the right is the color, and you can see that, right? So this is the back of the system. This is the front of the system. You're sitting in front of the system with the standard light source, D65, D50, D75. And so this is the right, is the whole structure of the system, okay? So so what is the theory behind, right? So I call this the additive and the subtractive. I apologize for that, right? It's additive and subtractive. So all the displays, right? The mobile phone, the home, TV, all this, right? We are using RGB light to mix the color. This is what we call the additive, okay? The basic of color science. Another one we call it the subtractive. So it's basically the colors being absorbed by the sample. Typical process is textiles, okay? So we have the color mixing together, right, with the dye absorption together. So we form this is the display technology, okay? I will also report its accuracy, repeatability, and the color matching performance. So this is the color gamut of the displays, okay? So we employ the 6 channels, but normally we use the 3 channels, okay? It produces a very large color gamut than the conventional dye process. And we are using the 3, color order systems here, Mansell, NCS, and the DIN. They are all the pigment, systems. You can see their color range in terms of red color, green color, and the blue color. They are well within our color ranges. This is in the C-lab diagram, AB. This is L against the C. The darker colors here, this is lighter colors, and so this is AB. So it's a projection of the color space, color gamut. And also, right, we do this, right, using a characterization of the systems. We applied this the 9x9x9, which we use a lot, right, in the digital printing, and also, right, is the mobile phone, okay? So we measure 9 by 9 by 9. So some people even measure using the 16 by 16 by 16, fine, okay? But we use the 9 by 9 by 9 lookup tables, okay? So, but our, and the sampling is unequaled. We find, right, equally spaced in RGB, we don't get good results. But we use the non-equal RGB, but they, according to the, arranged according to the L star, and we get very good results, okay? So let's have a look at the color reproduction. So we have 74 textile samples. They have different textures. They measured using the, data color systems, okay? SF, and the 600. And then, so reproduce the color measured by a telespectral radiometer, 0.81 units, okay? So the average delta E in CIED 2000 is the 0.81, okay? The color repeatability, we have the 50 colors repeated measure 6 times throughout the whole, 3 months period. So we can get a 0.5 delta E. So this performance is typical. That is what we expected, okay? So we also have the, develop the modeling to, reduce the flare. So what we found, right, is because in the booth, we have the light, we can adjust the light to the bright and the medium and sometimes low. But we have the, optical model to correct it's the, and the flare. So this is delta L, delta C, and the delta H, okay? So this is, right, is no corrections. And the red colors, these are the corrections, okay? So now we are very confident. So you can adjust the light level from the bright to the dim, and you can change different illuminance in the light bulb, in the light booth, and we can accurately predict the color difference within about the mean delta E 0.8. The colorway, this is for color selections, okay? So, so typically, right, is we applied the, and color books, such as the, Mansell, Colourists, Pantones, that's it. But we have some limitations there, okay? So one is, right, you should always look at the samples in the standard light source, okay? If you are in the Illumina A, there's no guarantee the actual appearance is what you want, okay? You should always in the standard light source. Color range is limited because, right, the designers always like to have the colors, right, in between. It's very few to have exactly the same colors, okay? So finally, right, is the fixed materials. So you always have the, let's say, the paint or the one type of the, fabrics, okay? So can we, improve this, okay? The basic, and the selection is still sticking to the color books, okay? So after that, the color can be reproduced. But if you want the more accurate colors, so you can come to our systems. So this is experiment being done very recently. So, and we have about 75 pictures, okay? And we use the Mansell, NCS, Pantone, together with LEDSimulator systems to select colors. We have 10 observers to do it. And the color way to do it, right, is we have the color wheel. This is the NCS, okay? So, and the pure red, yellow, green, blue, unitary hues. And we have the chroma range, okay? And finally, we have the fine selection areas, okay? So, and 20 observers to judge this, 75 images. And so this is okay, so we compare the performance, okay? The performance will be reported, elsewhere. So what we verified is the LEDSimulator is fast, quick, and accurate, okay? And And this is another experiment, okay? 20 designers, okay? We send the samples to different designers. Designers come, and then they do the color matching. And after they do the matching, and they measure using the jetty, okay? And I'm sorry, right? This is the matching performance, right? Is by the designer I just mentioned. This is the NCS results 6.1, data E, Munsell 6.5, and the Pantone is 7.1. And the LEDSimulator, we got about the 4.5. So everybody will have a different color vision. So when we do the color matching, the results will be different. How good you expect? So it's about the 4 to 8 color difference range, okay? But the tool, the better tool, can give you the more accurate results and also the quicker time. So this is NCS, this is the Munsell, Pantone, and LED, okay? And our LEDSimulators, you can see the right is from the 40 minutes comparing the 100 minutes to look at the 75 colors, right? And it's faster and more accurate, okay? Pantone is very interesting, right? Pantone, because it doesn't have the large number of the colors. So when you do it, it's quick, you know, but it's inaccurate, okay? So, and this is the result we got. And the new development now, right, is we are very much on the non-textile. We call it non-textiles. So we have the right is the step motors to control the viewing angles, to shine the light onto the object. The object also have the step motors. So it's an interaction. So you have two to control the illumination LED panels. And you have one to control the tilting of the samples. And in front is a measurement systems, okay? So this is right, it's basically saying, I deliver these samples to you, okay? I will not just have the color and texture information, but also, right, I will give you the geometry. So once they receive the geometry, and then the step motor will automatically change the angle of tilting and for you to judge the quality in that particular geometry, okay? So new developments also including, right, is virtual texture, virtual gloss, virtual translucency. The lady there is a dummy, okay? So it's very famous, right? Especially in the cosmetic area and the imaging area. So we can shine the light from the back. We can control the degree of translucency and adding the light from the top. So this is cosmetics. We play together. So we have the impact of all the different attributes to the final product, okay? Textile, the glossy textiles, and different textures, okay? Also, we work on the reflectance, the retrieval. So you have the LAB. Currently, we deliver LAB for color reproduction, and then in the very near future, we will be able to use the reflectance as well. So the Dyers, you get the reflectance or LAB, and you can get your recipes very quickly. And finally, it's a customized shade library. So any customers, you can put your library into your shade library, okay, including reflectance, all this, and we can arrange them in a 3-dimensional way, okay? So, and in summary, right, I will use this slide, okay? So why LEDSimulator? The first is a faster product development process, okay? So we can, you know, make the whole design process from the months to, you know, from years, from 3 months down to the weeks or days, okay? Color exploitation, this is to do with color design. So we can help you to design your color with designed, you know, texture. So putting together, so your customer will be happy. They don't need to, you know, really streaming the texture for you, okay? And then you will, you know, reduce the lab deep time, okay? And save the, you know, time and energy. And the next one is for color specification. This is for the branders, okay? So you can add in the information, right, to your textures. You can add a camera. This is optional. So once the color texture is being designed, the camera can move in to take the images, integrate with your digital design process, okay? and the color manufacturing, total appearance, the manufacturing. So when the Dyers, right, in the lab, when you produce the sample, you can compare with the virtual sample side by side with a very close agreement, okay?